Okay, we want to talk about motor control circuits today. And motor control circuits can be fed three different ways. Before we talk about that, we should talk about what does the code say on this subject. And let's go to 430.72. And we find that it says overcurrent protection. General, a motor control circuit tapped from the load side of a motor branch circuit, short circuit, and ground fault protected device, and functioning to control the motors connected to that branch circuit shall be protected against overcurrent in accordance with 430.72. Such a tap control circuit shall not be considered to be a branch circuit and shall be permitted to be protected by either a supplementary or branch circuit overcurrent protection device. A motor control circuit other than such a tap control circuit shall be protected against overcurrent in accordance with 425.43 or the notes to Table 11A and Table 11B in Chapter 9 as applicable. Then B, conductor protection. The overcurrent protection for conductors shall be provided as specified in 430.72B1 or B2. Okay, and then it has the three kinds of supply. Number one, separate overcurrent protection. In other words, like if the circuit is actually coming from an outside circuit, such as a lighting circuit, where the motor branch circuit, open circuit, and ground fault protection device does not provide protection in accordance with 430.72B2, separate overcurrent protection shall be provided. The overcurrent protection shall not exceed the value specified in column A of Table 430.72B. So separate protection or separate control is column A in our Table 430.72B. Now let's look at 2, branch circuit overcurrent protection device. Conductors shall be permitted to be protected by the motor branch circuit, short circuit, and ground fault protection device, and shall require only short circuit and ground fault protection where the conductors do not extend beyond the motor control equipment enclosure. The rating of protection devices shall not exceed the value specified in column B. So column B is for when the conductors stay inside the control equipment. In other words, if your push buttons are in the front of the starter. Okay. And C, control circuit transformer, our favorite, where a motor control circuit transformer is provided. The transformer shall be protected in accordance with 430.72 C1, C2, C3, C4, or C5. And so that's our column C. And so our separate control, we can have different size wires. And I want you to take a look at the column A. And it says, if you're using number 18 wire from a separate circuit, you could use a fuse of no more than 7 amps. Well, that only leaves one fuse. It's a standard fuse, a 6 amp fuse, right? Okay, and if you're using a 16, you could use a 10 amp fuse, okay. And then from there on, 14, 12, and 10, we have a note, and it says go to 3, 10, 15. In other words, go to the wire table, and what is it good for otherwise? And we know what that is, so we're not going to talk about that. That's not a big deal today. Generally, that's not a good idea to have a light control circuit coming and supplying your motor control circuit, because you don't know, you're going to have signs all over the place that this control circuit is coming from someplace else and is not turned off when the disconnects in this system are turned off, right? You're going to have all these special warnings and all kinds of fun stuff. And then B is generally for where you're just wiring inside the control cabinet, and that's not too big of a concern either. So column C is really where we're going to live, as it were. And I want you to look at where they extend beyond the enclosure, which is generally the case because you're going to have start-stop stations other places. You're going to have jog stations other places, not in the control cabinet door. Okay, now let's look at that column. Hang on. Okay, look to the far left and you'll find the control circuit conductor size, and that applies to all three columns. So at the top, we have 18, and if we come back over here to where it says copper, it says 7. So what does that mean? We could have a fuse or disconnect no more than 7 amps. For 16 wires, 10 amps again. Now, in common control, my note has disappeared, where I had the fuse disconnect in motor number 1 would be a 10 amp fuse. And we could use that in our column B application where it's not leaving. And that would be a common use, to use common control from a 10 amp fuse, and we don't have to fuse it anymore. We can take that directly to a control circuit. But better than that, we could take a control transformer from any 2 phases and get our supply circuit. And if we use 16 wire, we can go all over the place. As long as we have a fuse, it's 10 amp. So we'd have to have a fuse holder that's a 10 amp fuse holder coming from the supply circuit on the load side of one of these fuse disconnects. Everybody understand that now? And so we'd run around with our control circuit, and it would be fused at 10 amps, and we could use number 16 wire. Now, I know very few people that do that. And I'll tell you why. Because then you're carrying around a roll of 18 and a fuse block and some 10 amp fuses just for this situation. Whereas if you just use 14, what is my ampacity? Up to 45 amps. Up to 45 amps. So I could have, remember, this is not a circuit that's going to, if it's going to go short, it's going to go phase to phase type thing, and it's going to turn itself off very quickly. So 45 amps is not a big deal. And generally we don't need to do that. We'll have a 15 amp circuit breaker or a 15 amp fuse that will be supplying the control circuit that we can set up inside one of the motor starters. And we could supply all of the control circuits with one control transformer, right? Because a control transformer is not going to see a lot of load. All we have is some push buttons being pushed, or, you know, and what's it doing? It's just pulling in a little coil. And we've measured the current that's in those little coils, right? And it's way less than an amp, right? So we could supply a lot of stuff from that, but you need to know that you might be asked on the journeyman exam that if you use number 18, what size fuse do you have to provide to protect that wire in a motor control circuit? Okay. And with a number 18 wire, you would have to have a number 7 or smaller fuse. So we'd have to use a number 6. All right. Pretty simple stuff. Except for we're going to have wire. Let's say that we have our control transformer in our largest motor starter. That means we're going to have little control transformer in here, and we might be taking a pair of wires to each. Actually, I've drawn that incorrectly, haven't I? Let's try that again. If we have a little control transformer in this motor starter, we're going to have to bring our supply down to each motor starter, right? Now you're thinking, oh, I've got mixed conductors in a conduit, and I've got to upsize my conduit. Except that it's just not true. Okay? I don't know why I can't get rid of that. I still have that. Okay, cool. So the good news is that my control circuits aren't going to count for conduit fill in this one particular case. But I do want to talk about conduit fill where we're taking the conductors for several motors in one conduit. But we'll do that as a separate lecture another time.